Our panelist will be Yuvrender Gill. He's a software engineer at BenchSci. Very nice to have you. Simba Khadder, yes, CEO at FeatureForm. And Shabnam Mukhtari, head of operations at FeatureForm. If you'd like to introduce yourself, thank you.
Hello. Okay. Hi, everyone. Thank you so much for coming to the last talk of the day. Like he just mentioned, I'm Shabnam. I'm head of operations at FeatureForm, and I'm super excited to be here. It's been a blast meeting everyone in person at the conference. And yeah, I'm super excited to moderate this discussion on feature stores. I'd like to introduce our panel. So today we have Yuvrender Gill, who works on MLOps at BenchSci, and Simba Khadder, CEO of FeatureForm. Yeah, I'd love to give you guys the chance to introduce yourselves.
Yep. I'm Yuvrender. I'm working at BenchSci. It's a Toronto-based startup in biomedical AI. I'm working in the data team, so working on the ML pipelines and MLOps, and in general, like working with the feature stores. I'm also consulting a few startups based in Toronto and helping them build their ML systems and helping them scale their ML system reliably and using like different technologies like feature stores extensively to help them grow their ML systems.
Cool, and hey everyone, I'm Simba, CEO and co-founder of FeatureForm. A little bit about my background. I was at Google for a bit, left there, started my first company where we were at our peak handling about 100 million monthly active users. We were doing recommender systems, all kinds of models on a ton of data. We built something internally which we called our data platform. Nowadays we'd call it a feature store. So we were hipsters, we did it before it was cool. And yeah, and now I'm the CEO of FeatureForm, which is the virtual feature store.
Sweet, so let's jump right in. Feature stores can be a bit confusing, and depending on who you ask, you'll get a different definition. There's also quite a bit of variation between the feature store offerings on the market. Yuvrender, let's start with you. How would you define a feature store?
So my definition of feature stores is it's a piece of technology in your ML workflow, which lets you store features and help them serve in the training and the production simultaneously, and it helps you increase the reliability and performance of your overall ML system at a feature layer.
Got it. Thank you for that. Simba, how about you? You've had experience building feature stores at your last company, Triton, and now at FeatureForm. What do you think a feature store should be? Yeah,
I think a lot of the confusion of feature stores comes from the fact that there's a lot of completely different design patterns for them, but we call all of them feature stores. For example, like we just wrote a lot about this, but I generally break feature stores up into 3 types. One is what we call the literal feature store. With the literal feature store, it literally stores features. There's no transformations involved. Whereas what we call a physical feature store, which is this big Spark-like thing that does all of the transformations and all of the storage. This is what most teams built internally, because lots of the problems, like a feature in my head is the transformation is part of the definition. The issue that we found building that, and that's kind of what we built originally, was that it's really heavy. There's lots of vendor lock-in. And honestly, lots of the value of a feature store is less about the infrastructure problems and more about the workflow problems. Like data science in general, like how many times like I've found I'm like on my Jupyter notebook and it's like my file is untitled _110 and I have some transformation I wrote and I have to remember to copy and paste it later to put it in production. That was like our problem. We didn't have a workflow. Whereas in software development, we had DevOps, we had all of this process. So for me, a feature store is less about infrastructure and more about workflows. Providing a workflow for data scientists to define their features, to manage them, and to serve them in production, and even in experimentation. It makes that whole process faster and cleaner, and really increases reliability.
So to add to that, so you're basically removing the DevOps and like the operations part from a data science data scientist's job and let them focus on what their actual job is to model and like build different models and work on their specific machine learning like algorithms or.
Totally. Yeah, I think that it's like, again, like with DevOps, like when you write an application, you don't have to worry about writing some bash script and like putting instances up and getting it on those instances. Like those days are gone. You just push your code. And in ML, like that's where MLOps, I think, should get us to.
Yep.
Awesome. So let's take a step back. Oftentimes when teams are looking to explore MLOps in general, some folks will say that they should start with a feature store. What are your guys' thoughts on that?
Yeah, so I mean, in general, I think that especially if you're working with tabular data and text data, most of the time you're not really working on the model. Like the model is kind of a black box. Like you have hyperparameters, it's different architectures, but really like most of our time was spent getting signal out of our data. That's where we saw the most value. That was repeatable because we understood why things were happening. Sometimes we'd implement some model from some paper we'd read and it might do better, but we don't know why, and it would freak us out to put us in production. But with data, once we got some new feature and it did better, we were pretty comfortable that that would actually work in production. So in general, like if you look at a data scientist's time and you're doing, again, like tabular data or NLP, anything of text, you're probably spending most of your time on the data part. And if you're trying to optimize the ML process, you should focus on where you're spending most of your time. So if that's the case for you, then a feature store is going to be the most bang for your buck.
Yeah, I've found that being a problem at a lot of startups as well. You have a lot of new data coming in, and you have to constantly update your models. And features are the most important like input layer for providing signals to your models and improving your models over time. And if you are able to use a piece of technology which enables you to version and then reliably update your features in the training as well as in the production, that's like where the major optimization comes in the ML workflows. That's like from my experience. And feature stores have been a really cool tool to achieve that specific optimization in the ML workflow.
Got it. So feature stores are a good place to start. Great. Yuvrender, you're at BenchSci, and as a practitioner, I'd love to learn more about how you guys implement a feature store now and how it fits into your MLOps stack.
Yeah, so in my experience, most of the work that we have done with the feature stores is primarily to have some sort of integrity between the training features and the production side features. Because there's new data coming in the production, and then we have features being calculated on the production side, and we are also updating our models in the training side as well. So feature stores provide that reliable layer where we can have the training and the production side features in sync, and we can reliably say that what we have in the training, we are providing the same results or like the same expected results in the production side as well.
Got it. And how would you like to see your feature store evolve at BenchSci specifically?
Yeah, I think in general, like where the feature store technology is going is you can't just be just storing the features and have them in sync. A few things that like the feature stores, where I see the limitations are that a lot of the feature store solutions, they provide you with their own tech stack that you're locked in. And especially for like startups, or even if you're trying to build a very large scale feature store, you want to have your own custom components. So that's like a major area of contention where you are not able to plug out of the specific technology to store your features or to process the transformations in your feature store. So you would want those parts to be plug and play, and you can test out different technologies, you can test out different benchmarks, and based on those benchmarks and your particular needs, you are able to use those technologies along with your feature store. And feature stores basically should look more like an abstraction where you can define some sort of workflow around your features and not just being stuck with like the technology or like the database the vendor provides you. So that's like one example.
Yeah, I mean, I definitely, like, we found the same thing. Like, when we built it internally, it made sense to tie it into our infrastructure because we just assumed it wouldn't change. But now, especially now being a vendor, like a big thing that we've really focused on and realized as we go to all these different companies is there's two kinds of problems to be solved. There's the organizational problem and like the processing problem. And I realized that we could solve the organizational problem, like all that's workflow, without having to solve the processing problem, without having to replace your infrastructure, with just taking the infrastructure that's already there and already exists and putting a workflow and abstraction on top of it, built for data scientists building features. Like that's kind of what we are. We're just kind of that workflow abstraction layer. And I think why that works is that, especially if you get to more complicated deployments, like you might have teams of different databases. You might have teams that are using Spark in some places, Dask in other. You have teams that have embeddings. Like all of these things are features and part of the feature workflow. If you just have one storage layer, you have to either build this crazy omni storage layer that does everything, or you just let people put their data where they want to and transform it where they want to and provide that kind of orchestration and workflow layer and all the metadata layer, which is kind of how we built what we have.
Yeah, and I see that solving one of the biggest problems is that, say you already have infrastructure built in, right? A lot of companies, or a lot of, especially like big enterprise, they have some sort of, not like formal feature store, but something very similar built in to have their training features and then their production features have in sync. Not necessarily using a feature store like solution, but what's going to happen, like, how do you introduce a new technology? If you just have an orchestration or like abstraction that you can say, like if you're using BigQuery and you can just integrate BigQuery directly with that abstraction, and that abstraction gives you, it's just a set of instructions how your features will be processed. It's way easier for adoption at like that like big enterprise level, or like if you have already built something and you don't have to get like a lot of buy-in and like deal with all the compliance issues to get this new piece of technology into your workflow and then getting so many approvals.
Yeah, one thing you've mentioned a few times is kind of that sync between training and serving and like inference. And one thing that I think a lot of people don't think about when they're thinking about their feature store, whoever they're building or buying, is the syncing between experimentation and deployment. Lots of experimentation also happens locally, like in just a notebook. And in our world, like in your notebook while you're working and you're building something, every time you build a resource, you kind of push that resource to the feature store. Like, hey, this transformation is interesting, I might want to reuse it again. Like, I'm just going to push it to the feature store. What I used to do literally was like copy and paste to Google Docs. Like that was like a super common thing I did, and I kind of learned from that. That's part of why at the last company we built that kind of feature store thing. It was just to provide that repository of things. One thing we've also seen a lot of, and I'm curious to if this kind of is something you guys see at BenchSci, is access control and governance. Like that becomes a big thing. A lot of people treat like feature stores as just the kind of, this is where the features are created and stored. But a lot of what we're saying is that the feature store becomes very smart and can do things like, hey, like this model should not be using these types of features, like PII features. Or we were just talking to someone who has this whole 6-month legal workflow. Every time they create a feature, they have to go and send it to legal. It's a major bank. And so everything goes through this 6-month cycle. So they're like, yeah, our biggest problem isn't even like technical. It's literally just like our workflow of legal. And I think that that's something that could be integrated into how like a feature store works. It kind of becomes this layer where everyone who's dealing with features kind of works through it. Whether you're like, you can encode like this workflow logic, whether like who can see what, who can use what models are allowed to touch which features, et cetera.
Yeah, and to add to that, it's not only just like what kind of data you're using. Say like if you're operating in 2 different geographical locations, one in North America and then the other one you're like operating in EU. They have different set of rules around like what kind of data you can use. And feature stores make that very easy to allocate the policies around your features and how your models are using those features. And you can allocate a policy for EU, one for North America, and you can easily get around that compliance cycle other than just like building logic in your like data pipelines. That's way more complicated. And feature stores provide you this abstraction layer, which is like really nice to have and increases the velocity of the overall like your MLOps team.
I'm curious. So like when we first were doing this, it was funny. We had a conversation and we both realized we had the same view of where feature stores were going, which worked out well. But we obviously have that virtual feature store idea. That's something we've kind of built around. And it sounds like you came to that same conclusion. I'm curious, like, what made it click for you? Like when you were like, hey, a feature store is an abstraction or should be an abstraction and not a piece of infrastructure.
I think a lot of things just come from like day-to-day discussions around like my clients that I'm dealing with, like a lot of like inflexibility of previous feature stores that we discussed, and then we started building our own like data infrastructure, and we started like building like the plug and play elements, and that's where like it intuitively came into mind is that this is how it should be. And from the very first iteration, this is where it should be going. And especially like as companies are moving from more batch to online systems, like online inference, I think that's just like a very natural solution to have some sort of abstraction, because with abstraction you can do a lot of like client-side processing as well with those abstractions, and like build like small models on client side and then compute the features right on spot and keep them in sync with your historical features as well.
Yeah, so you guys kind of touched on this. I had a question myself. You've covered like enterprise use cases of feature stores, but also smaller teams. Simba, I'll start with you. Can you talk a bit about like feature store adoption and the different stages of it, I guess?
Yeah, I mean, I guess where you're kind of getting at is like there's like the enterprise use case. We talked a lot about like big companies, teams. I think one thing that I've talked about it a little bit in different places, but I've kind of come to the conclusion that if you're a single data scientist, you would have a feature store. The same way that if you're a single software engineer, you use Git. Like we all use Git when we're working alone, and it's kind of, if you could imagine like the time before version control, before Git, like the idea of like, why would I use Git? Like I'm fine, I'm just writing my code. When I want to edit it, I'll just edit it myself. Like now that would be really weird and very strange, but feature stores are kind of the same thing to me. Like I feel like you can be a single data scientist, like, I mean, I play around when I'm using FeatureForm, playing around with it locally. Like I will actually just push features and transformations to it. Just working alone, there's no infrastructure, like there's no storage, it's all on my computer. But I still like use it as a means and a framework to keep track of our features and our logic. And yeah, anyway, it's kind of I think as we think about the future of feature stores, I think that feature stores just become as a part of the workflow like a notebook is. Like everyone just uses notebooks everywhere. I don't think that's going to change anytime soon. I see feature stores being a similar thing. I just wish I had a better name because the feature store name like adds some confusion about what it is, and it would feel weird to use a feature store. But if you think of it as like it's my data framework or something, it kind of starts to become obvious that that's the framework you would use even working locally.
Yeah, I feel like from the name part, I feel like in future, I don't think we will be talking about feature stores. It will be something like feature orchestrator. Probably some cooler name, but the idea will be that you're orchestrating the features and the workflows around them, and not just like talking about storing the features, which the feature store, like right now, that gives that idea. But we're going towards like that orchestration stage. Yeah.
The FO, the feature orchestrator.
Yeah, exactly.
Awesome. So we're getting close to closing out. Any final thoughts on the future of feature stores?
Yeah, I'm like super excited to see like this new approach being adopted, and so many like new companies which are working in the like MLOps environment. They're thinking about this approach, and to see like where we will be in next 2 years. I think this piece of like idea of like orchestration of features will be very mature, and I'm happy that we brought this idea in this panel, because probably it will be it's the first time this idea is brought and might be the mainstream in 2 years.
Yeah, and we think so too. So we definitely kind of final thoughts. I mean, obviously, we have our feature store. We built it with the same idea in mind. It took a few years of thinking through it and working with different people before it really clicked. We had that same click moment, and then we just kind of almost built from scratch around this new idea of a feature orchestrator, pretty much, as opposed to a feature store and feature transformation layer. I think one thing I'll add, which is a little bit maybe now the scope of feature stores, maybe future of MLOps, is I think MLOps as a whole is a workflow problem. Even monitoring and all these other pieces. I think that there are lots of really great infrastructure for these different things. We use Prometheus and other things not for ML, but for just other things. And I think that what's missing in a lot of those cases is making it all fit together coherently for an ML workflow. So I guess future of MLOps is a lot of companies here kind of turn into HashiCorp-esque products where they're all just kind of lightweight abstractions that make your current kind of infrastructure work together coherently as a feature store or as a MLOps platform.
Yeah, and feature stores and the other piece of technology that's coming in is model stores as well, which help you version the models and store different metadata around your model, and then just use that metadata to actually implement that model downstream. And that's where we are seeing this whole MLOps going towards, is more defining your workflow and not focus on the other layers. All you gotta do is focus on the problem. This is the overall workflow, and this is how we plug and play different parts, and this is how we optimize, and this is how we increase the velocity over time of our MLOps team.
Awesome. Well, thank you, Simba and Yuvrender. This was a great discussion. I'd love to leave some time for Q&A. Does anyone in the audience have any questions?
Yeah, there's a mic up here too if you want to come up and ask.
Yeah, I have a question. Oh, sorry. Yeah, I have a question. You actually talked a little bit earlier about this, but I just wanted to fix it. You talked about the difference between a literal feature store and a virtual. Can you talk a little bit about that, please?
Yeah. So for a literal feature store, my framework is there's 3 types. There's literal, physical, and virtual. The literal feature store is you would transform your data somewhere. Let's say it's Spark. You would then push it into the literal feature store. So the feature store in this situation is literally storage for the features. The value prop is that typically you would have a training store and an inference store, an online store, offline store. There's a lot of different things you can call it. That literal feature store aims to consolidate the two. So you would have training and serving be using kind of the same data or same features. The problem that we've seen with teams that have started this approach and have come and spoken with us is that as they're iterating, this works really well if your features don't change much. But the issue is that they do change a lot. That's the whole point of kind of MLOps, is to make iteration happen quickly. Well, if you're iterating and you create a new feature, all the transformation layer, all the versioning around the transformations, all that logic happens elsewhere, outside the feature store. So there's a whole slew of problems to be solved there. And every time you change your feature, you now have to create a new table in the literal feature store, write it there, point your model at it. So every change, I've actually talked to people where they're like, it's actually worse now that we have the feature store in, because it's added more headache and it's not really the right puzzle piece for the problem we had. And then I'll just quickly go into the physical, does the transformations, and the storage. So it solves that problem. If you think of what Airbnb built and a lot of these other big companies built, it's the physical feature store. In those situations, when they built internally, they built with the processing engine and the storage engine built in, which is great if you're an internal team and you're like, yeah, we're going to be around forever, we're going to support this thing, this is how it works. If you're an external, especially if you're using a vendor, or if you're a global enterprise and you have lots of different teams, they're going to use different, if you're using Spark in your physical feature store, as an example, you can't do anything that DAS does or anything that Flink does. There's specific things that different, or embeddings, all this different stuff isn't possible. You're kind of locked into the underlying infrastructure. And the virtual feature store idea is hey, what would happen if we tried to take whatever infrastructure they have today and make it work like that physical feature store. That's kind of where the idea came from, was like, can we just provide that abstraction and workflow on existing infrastructure? That's the virtual idea.
Okay, got it. Thank you very much.
Of course.
Yeah, I have a question about this idea of like feature orchestration or virtual feature store. So if you have your current infrastructure, and we have our online or offline different ones, right? So we have online like can be Redis, Cassandra, and then offline the data lake. But is this the virtual feature store also in change of syncing then? Or is that you already need to have also your own infrastructure to, or your own kind of processes to sync between the two of them? Is that part of the work that this virtual feature store idea does, or is that something that you need to do?
It's a really good question. And the question, just to make sure I understand it, is one common operation in the feature store is to sync between the offline to the online.
Or the opposite.
Or opposite. And typically, like, what we see, I'll use Feast as an example. Like when you do this with Feast, you use their CLI, it will actually download from the offline store and then upload to the online store, because it's such a weird problem, because it's like, it needs to happen somewhere. You need some sort of compute to do it. The way we do it, like in FeatureForm, there isn't really like a one answer, but our approach is we've made ourselves Kubernetes native. We need Kubernetes. So for certain things like glue that we need, that like the infrastructure doesn't do, we'll just spin up Kubernetes pods to make it happen. So in this situation where we copy from the offline to the online store, we'll actually kick off a Kubernetes job that will actually copy it over.
I can add to that as well. Like how I see it as a general problem is that you have this metadata layer where you define this global state that you want, and then the provider, like whoever is providing that feature store, or like the virtual feature store, you can say, is gonna guarantee that you have that global state that you defined with your metadata. How they do it, like underneath, like what compute they are using, that's their like problem to solve. But what you are saying is that I want this state, and they're gonna guarantee that this is the state you're gonna get. And that's, I think, like where this orchestration philosophy goes towards, is like defining the state and then forget about it. You're using your own infrastructure at the back end, but like how that state is achieved is that orchestrator is managing that process.
Okay, thanks.
Thank you so much for a great panel. I do have a question instead of the app itself, and it's probably a very loaded question. So with so many feature store vendors who are out there, who has the better roadmap for the future?
Us, obviously. I don't know how to answer this question. I mean, do you want to?
Yeah, I can give you a practitioner's point of view. I think first of all, like you should think of it as a long-term solution because your problem space is going to change. Your domain might, like your domain-specific problems might change as well. So if you're an early-stage company, then you want something which will provide you flexibility once you will scale to a certain level. Or maybe you can start with something which doesn't provide you that flexibility but provide you ease. So you can start with like an early adoption, but always think of like how you're gonna scale, what makes the scalability easier. And then if you're locking in with like some sort of vendor which is providing you their own storage and like own like other logical layers, you want to question yourself that do you want like to lock in with them? And even if you want to lock in with them, how long do you want to be locked in with them? So I think asking these questions and seeing like which vendor is providing you the solutions and the most flexibility around those questions is the way to think about like which vendors to go towards. Because we will probably see a lot of them coming in, and especially in like next 2 or 3 years, because online inference is becoming a mainstream thing with bigger companies and even smaller startups. And that's like the definitive answer is like, ask what problems you have, how you're going to scale them, and then see like who is more aligned with your solution. And think about like timeline of like how long you want to be stuck with them, and then how like hard it will be to opt out of that thing.
I'll add a little bit, and just in general of like MLOps vendors, is a lot of them have try to figure out what their vision is. What's their view? Like what's their perspective? What makes them different? Like one thing we get a lot is like a lot of people come to us and they'll say, yeah, I talk to all these feature store companies. And I will sometimes not even tell them what a feature store is or why it's useful. I'll be like, you've heard the same pitch 7 times. I'm only going to tell you what makes us different. And I think that's a really key thing as you're thinking, is think about what their different perspectives are. Because that's really what you're buying into. MLOps is still so early that at this stage, a lot of vendors are getting towards that kind of feature completion. But until they get there, like you need to kind of figure out not just where they are today, but where are they going and how will it be different, and do you align with that view of the world? Because like the literal, physical, virtual, there are pros and cons to each. There's no like perfect way to do things. We have the view that virtual is the way to do it, but understanding like where they're going and why, like if you align to that, that's probably one of the most important pieces.
Yep, and that's all I have.